Look out, this one's going to be fun. So, I'm just curious if we could geometrically represent an expression like that, x squared plus 4x plus 3.
Very careful. Very careful.
Okay.
You use a forbidden way of foiling things out like that, or?
Huh? I just want to know if you could draw. I just want to know if we could draw a picture that represents that. Can we get the factor? Oh, please don't get all fancy on me. All right, stop. Let's take a deep breath. Everyone close your eyes. Convolution, convolution. All right, the first question is, how many terms do I have? 3 terms. Agreed? Agreed. Okay. First term is what? X squared. What does x squared look like? Hint. Rhymes with a square of dimension x by x. Right? That's what an x squared looks like. Yes, no, maybe?
There.
That's what an x squared looks like. What does 4x look like geometrically?
4 by
It's a rectangle, right? So notice over here in this example we had a 3x rectangle. And the 3x rectangle was as tall as our x square, but only 3 wide. Right? So the 4x would look like a 4 by x. Right? Everyone buy that that's x tall? Right? Because I've said it right there next to. Now what would 3 look like geometrically?
3 by 1.
3 by 1 or 3 1 by 1s, right? That could work. Everyone buy it? That would be a way to geometrically represent an expression. And of course, I suppose I should be careful here. That's 4 by x, so it's a 4x, and that's an x squared. And those are all 1 by, right? 1 by 1s. Okay. Seeing that we did the first one together, now this is where the audience participation comes in. Let's see if we can draw those. X squared plus 6x plus 1. Does everyone agree that 4x rectangle could be separated into 4 1 by x rectangles?
Yes.
Yes.
Just making sure. Could we do something here?
6.
Break it into 6. 1, 2, 3, 4, 5, 6. So we've got 6 little rectangles and a 1. Now, geometrically, what shape do we have over here?
Big square.
A big square. And squares,
Or square.
they rule. They're cooler shapes than rectangles. Because why?
All sides are equal.
Because all sides are equal.
Yeah.
It has cool symmetry. Flip it over, spin it around. It's all kinds of cool stuff. So, can I arrange that stuff and make a square? Start with the big one.
Flip those guys, the little ones. Vertical.
Flip those guys, the little ones. Which? Those guys,
Then
the
1
little
by 1, split them. So
Flip these ones?
they're arranged vertically and then added to the 4 by x.
What do you want me to do with my 3s? I'm game. Absent any other ideas, I'll run with it.
You can, the 1 by 1s that you have in
Where do you want 'em?
vertically, you can arrange them vertically and just, sort of like that.
Like
And
that?
then join this by the 4 by x so you get a square or something.
Is that a square?
Not yet.
Not close.
That's okay. In this example here, we had 6 x's. Agreed?
Yeah.
With our geometric representation of the square, what did we do with our 6 x's? Hint?
Split it in half and then add it into
Yeah,
the
we had them attached to our x square, one to the side, one down on the base. So what could we do with our
Split it in
4
two.
x's there, split them into...
Put one on the side.
Okay, so let's do some drawing here.
Yeah, it'll be short.
So we've got our x by x, right? We're going to take 2 of our tall, skinny ones.
That's what I wish I was trying to do.
Agreed? Now, what about the 3 little 1x1s? Where can we put those?
Arrange them in the hole that's left, and it'll be one short.
So you notice, of course, that we are 1 short of having the perfect square. Yes?
Yes.
So, you know what I'm going to do?
I'm afraid to ask.
Let's do it. Well, check it out. That's pretty killer. All right, now I've got a darn square.
It's totally illegal.
Whatever, dude. It's an expression. I'm just adding.
How could you compensate to make it back? To put
It
it
doesn't
back?
matter. It's an expression. We don't have an equation. I'm just adding that 1 in to make it geometrically nicer.
Kari, if I did that on our test, can I still get it right? Because Dave told me to do it.
Only we're getting there.
Okay.
But the point is, I could throw down 1 more little block, and what do I have?
Perfect square.
I have a nice square. What are the dimensions of my square? X plus
2.
1 plus 1, right? So we have created a square of dimension x plus 2. And all we have to do in this particular case is add in that 1 little guy. We squared it out. What could we do here? What would we do with our 6 x's?
Split them in half.
Split them 3 and 3. Put some over here, some down here. So let's...
And then grant yourself 5 more squares.
Eight more squares.
And we've only got the 1 little yellow guy hanging out.
Sweetie.
So how many would we need to fill that sucker in? We would need, well, let's write them in and count. That always works. 1, 2, 3.
Let's try it.
That rhymes with 8. All right, so we added 8 of them in. And what do we have here? And what does that square have for dimension? Right, it's an x plus 3 squared. By it. In the interest of time, let's look at this one.
I heard that.
The bottom one, not the other ones. That's where, of course, the issue.